Hey everybody, today we are talking about nutrients. This is a really important unit for us and I think is one of the main elements of our entire cultivation process here. So we're going to look at the essential elements, how we are going to apply them in person, and just a few other things with what's going on with this. We already know we went through the photosynthesis unit and we talked about what's involved with that process: carbon, hydrogen, oxygen, sunlight. We understand the process of photosynthesis, cellular respiration. We're just only going to talk about nutrients today. So we have our primary nutrients: nitrogen, phosphorus, and potassium. These will always be expressed in large numbers on the covers of fertilizer bags and stuff. It will say 1055, 1400. It is telling you the nitrogen, phosphorus, and potassium content because these are our primary macronutrients. They are soluble, they are active, they're moving through the plant, and are easily noticed if they are lacking, if they're deficient. We have our secondary macronutrients: calcium, magnesium, and sulfur. So that's why you see a lot of the time there'll be CalMag will be sold as a product. This is a very important macronutrient that is just important at the right times. And then we have micronutrients, which are going to be ever present throughout the mixes: the iron, manganese, zinc, copper, boron, molybdenum, and chlorine. And then you can see over here in this nice little diagram, they arrange them in matter of most important, the building blocks, NPK, and then moving downward into the secondary and micro. We at the lab use Athena. We have used Floraflex in the past. All of the math is very similar. It's the same process you're going through, but Athena does have a ton of resources, and we're using them because it's a little simpler. It's the Floraflex had a 4-part formula where Athena has 3-part, and so just due to our tank arrangement, the fact that we only had 4 active Dosatrons, we wanted to go with a 3-part and have that fourth pump, the Dosatron pump, using our pH calibration, the pH down. So we stepped away from the Floraflex and used Athena because it is only a 3-part, and in our opinion, it is it's nice and simple. There's tons of education out there, but no matter what nutrient you're mixing for, the math is pretty simple. It's pretty much the same. We're just gonna roll through these programs. I'll already uploaded a few of them, and you can find these on all of the company's websites. They're very transparent because they want their customers to be successful and know what they're doing. So they're, obviously their customer service, lines and stuff won't be congested with people asking, oh, how do I mix this? How do I mix that? No, it's like there's all these resources on the internet. So here we go. This is a simple schedule. You can see core, grow, and bloom. Core is used every percent. It is uh, basically just purely nitrogen, and then the grow and bloom will have no nitrogen and will just be phosphorus, potassium, and then the other micronutrients. So we can see they have this going for a 3.0 EC. You can just take these ratios and adjust them based on the EC that you desire. They have kept their schedule at 3.0 the entire length of the vegetative week 1 through 4 of vegetative, and then the 1 through 8 of flower with a week 9 flush. And also, I just want to say that this is similar to the kind of schedule that we're looking to make, except we will just have different values in here. I don't like doing a 3.0 the entire time. You could, but it's just not what I prefer. I prefer to do a gradual increase, and work it up and then work it down. So that's just how I prefer to do things. Everyone has their own way. It usually is going to work. So, but we can take from this is that as the ratios that they're putting in here, which this is based off of 10 liters. So all you do if you want 1 liter is you divide by 10. So 11.4 becomes 1.4, 19.0 becomes 1.9, and I have this denoted over here. This is used in liters. It's very simple to convert. I will also have the gallons up there as well. We're going to use a lower EC, and if there are 11.4 grams of core and 19 of grow, 10 liters, then simple math right there. If you want to target an EC of 2.0, then we want 1/3 less nutrient going into the mix. So 1.4 times 0.66 equals roughly just under a gram. It's 0.94 core and then This math breaks down to 1.3 grams of grow, and you can repeat this to reach 1.5, and you just use ratios like and fractions to achieve this. But I will also show you this next um, slide here on how they have that broken down on their personal calendars and ratio sheets. Let's talk about filling a stock tank. We will mix 1 pound per gallon into our tanks. We have 5 gallons, so 454 grams in 1 pound times 5 equals 2,272 grams going into each stock tank. Now we know exactly how many grams per milliliter are present. 0.12 grams per milliliter of nutrient are present in the water. So using this 1 pound mix, it is projected that if we want to reach a 2.0 EC, we will need 25 milliliters of core and 42 milliliters of grow. Since we know that there are 3,785 milliliters in a gallon, we can put this into a ratio and communicate to our dosatrons how to pump into the gallon of water that is passing through the dosatron. 3,785 divided by 25 equals 151. So if we set a 1 to 151 ratio of core and a 1 to 90 ratio of grow, then we will get the desired EC of 2.0. And if you think about ratios, a 1 to 2 ratio is bigger than a 1 to 4. So if I have 1 part of water or 1 part of nutrient and 2 parts of water, that means there's more nutrient in that 1 to 2 ratio than if I have 1 part of nutrient and 4 parts of water. There's more water in that diluting it, and thus there's going to be less nutrient present. So if we were to add an extra pound per gallon into our stock tank instead of 1, the ratios would be smaller. For example, since in that first one it was 42 milliliters of grow that would go into 1 gallon, the 3,785 milliliters, it would become half of that because we added more nutrient to the stock tank. The ratio would go from 1 to 90 to 1 to 180. We doubled the ratio because there's so much extra nutrient in the stock tank that we can take less of it out to reach the intended milliliters going into our nutrient solution. So we will, trust me, we'll do a lot of this in person, but it is definitely something to definitely get familiar with, that the way that ratios work should not be too complicated. But I'll go ahead and show you what this looks like on their schedules here. So you can see they have all this educational material out here to help their growers succeed, and so they get less questions. So it says these are the different ways you can do it. 1 pound per gallon, this is 1 pound in grams, 2 pounds per gallon, or 2.5 pounds per gallon. They recommend you stop at that point. They show you how to mix it and agitate it, and then also they show the dosage in milliliters per gallon for concentrate mixed at 1 pound or 2, or if you go lower, 2.5. Very simple, and this is great. This is so useful for all of us. You can see your target EC, 1.0, 1.5. Here, this is the one we were doing. 2.0, it recommends 25 milliliters of core and 42 milliliters of the grow or bloom, depending on which part of the cycle you're on. And then if you look lower, if you had doubled the amount that's in your stock tank, you can see the required milliliters is cut essentially in half. Very useful. Here's that feed schedule that we were just looking at. I'll scroll up and you can see that they have it in gallons as well. This is available free on their website to help their growers succeed for obvious reasons. We also have the nutrient labels here. This is core. You can see the 1400, so there's no phosphorus, no potassium, all nitrogen. It's total nitrogen, nitrogen, and then you can see there's a lot of calcium, and then small amounts of boron, copper, iron, manganese, molybdenum, and zinc. So this is very obvious. It's calcium and nitrogen is what's in the core. The next one is grow. You can see very small amount of nitrogen, 2, 8, 20. Available phosphate, 8%. Available potash, potassium, it's going to be 20%. Magnesium, 3%. Sulfur, 8%. Iron, 0.1%. And then we also have our bloom. The available phosphate, look at it again, 0 nitrogen, 12, 24. Phosphate, 12%. Available potash, potassium, 24%. Magnesium, 3%. Sulfur, 9%. Iron, 1%. So when we are mixing for our schedules, you can look here. It's pretty obvious. In vegetative, you're going to be using core and grow, which means you're going to have a lot of nitrogen. Let's see, here we go. Nitrogen, potassium, and minimal phosphorus. So we have very high, 14, so that's 16 of nitrogen, 8 of phosphorus, and 20 of potassium. So low phosphorus, high potassium, high nitrogen. And then when we switch to bloom, you will still be injecting core, but it is at a staggered ratio. It's not totally even here. There's going to be less nitrogen going into it. And then bloom, you're also going to have an increase in phosphorus and an increase in potassium as well. So it's very transparent what we're working with here. And so you go from mixing grow and coarse, a lot of nitrogen. And then you cut the nitrogen down once you start flowering and you add more phosphorus, a lot more potassium, and then you keep a nice and high EC through the flower cycles, and then you flush and you only use water through the rest of that. The cleanse here, this is intended, this is like one of their extra products. I don't use it, but it's intended to like flush the salts out of your pots and keep them from getting any problems with that from overuse of nutrients. But you can see this is based off of 3.0, so I'm avoiding the need for this, in my opinion, by just giving them less and doing like, feed one day, water the next day type of scheduling for my personal preference. So you can see that they have all of these resources in front of you. They even have Dosatron breakdowns of how to set this up with the different lines. Here's the Pro line, and I'm a big fan of this. If you have any questions on this, we can go over it over and over again until it makes sense and until you understand what's going on here, and we'll do plenty of mixing this week. I also want to note one more thing, that the pH down here, they have it at 5.6, and it says right here, cocoa and rock wool, 5.5 to 5.8 is their desired range. And then they go up here, that's in vegetative and cloning. Flower, they're saying cocoa and rock wool, 5.8 to 6.2. And then below it says peat-based, peat perlite, all that. 5.9 to 6.2 veg, 6.0 to 6.4 in flower because of the pH buffer of the soil. So just be aware of what medium that you are working with. And you can just go ahead and, if you're going to be using this line or any other, just look at the ratios they have and just do the math and figure out what's going to work for you and how to work with that. And if you have any questions, feel free to let me know.